actually, this is the first time I've been with this group, so I've learned a lot, and a lot of what you guys are talking about in the north. We actually, I know we're in the south now, but deeper south, some of the issues. So I just wanted to go through and show you some of the stuff we're doing at Blueberries, some of the things we're having to deal with, and then at the end show you some other row crop stuff. So this is one of those specialty crop projects that we started, looking at water resources, water management, really looking at nutrient movement underneath these blueberries, and I'll show you why with these wonderful drawings here in just a minute. But just kind of go through where we're working, what some side projects we're doing, and where we're going from there. So a lot of this started back in 2008. Georgia decided to do a Water Stewardship Act. It passed into law, and at that point, in part of that law, in the state of Georgia, we had to come up with and develop regional water plans. So Georgia was split. We got 14 major river basins in Georgia. Those were split into 10 river regional water councils. Atlanta's pretty much its own regional water council or group, and then there's 10 others around the state, so a total of 11. And you see here NPS 2 and NPS A1. Those are just two of the practice managements in most of these water plans. And the first one's looking at monitoring and determining nutrient movement, looking at how do we deal with nutrients in our water sources. We talked about hypoxia yesterday here in the Gulf. We have small pockets of that around some of the lakes. We got that little swamp down there called Okefenokee Swamp that we have to deal with Florida. So how do we deal with those nutrients, and where do those come from? And this project I'll show you is right on the edge of the Okefenokee. The second one is dealing with cover crops. I've been dealing with cover crops in Georgia for about 15, 16 years now. We've got a lot of farmers that are really in tune with conservation tillage. I get bombarded all the time, and I know Gary did when you were there. What are we doing about conservation tillage? How are we getting more farmers involved in it? How do we get more farmers involved with it? And then the economic side of it. How do we deal with the economics? So we're looking at conservation tillage and reduced runoff, infiltration, and those aspects of it. So what are we doing? Really just looking at, in this project, specifically looking at blueberries and how do we manage the nutrient movement below blueberries if there is that nutrient movement. So we're trying to monitor it and look at how do we deal with that. And then once we find it, or if we find it, how do we mitigate it? And I'll show you one of the problems we have in just a minute. So this is one of the locations, but this is the site of the blueberries, the top one. Did he do it? Cool. That's fine. So this is more from Web Soil Survey. The little orange lines are the outlines of the soil types. This is from Google Earth. It's the same site. But what I want you to notice on here is the orange lines. I hope you can see them right down through here, right down through here. These are drainage channels that were dug by the Corps of Engineers back in probably the 50s or so, 60s, to get water off of this land. If you dig a hole out here more than about 6 inches, you're going to run into water. So what they do is they dig it and they put blueberries in it, and then they try to drain it. But the issue is, this is Corps of Engineer water, and I found out from the county extension agent about a week and a half ago, the farmers can't use this water. They can dump water into it, but they can't use it as recycled water because it's Corps of Engineer water, and they have to get Corps of Engineer permits to use that water. So therefore, they can dump it, and I'll show you what it looks like. But so that's an issue we're having to deal with. And so here's the soil types. If you look at the soil types, it is mainly loamy sand. Stuff drains very quickly, 1.5 inches, 2 inches per hour when it drains. So the thought of getting nutrients, putting nutrients on these blueberries, and then that water draining down at 1.5 inches, 2 inches per hour, those nutrients are going to go right with it. If they're hitting a tile drain going out into the local creek or out into this drainage ditch, we've seen goes into the Altamaha River and then further on down. How do we deal with those nutrients? And especially if it's written into these water plans that we need to figure out a way to manage nutrients, how are we going to deal with that? So that's just the series. If you look at it, it's all gray dirt, gray soil. Sorry, I'm an engineer. I don't talk soil science terms. But So it's gray dirt, gray soil, and it's wet soil down after about 5 inches, 6 inches. So the way they make these blueberry beds, if you're not sure, if you're from Michigan, you probably know this. But otherwise, they go in and they'll take the land which had pine trees on it. They'll get the pine trees off, sell it for pulp or wood or whatever. So you've got this bare land now, wet, gray soil. They will go in and they will put 200 to 300 cubic yards of pine bark on top of this soil. They will then mix it in about 8 inches, so now they have this mixture of pine bark and gray soil on top. And again, these are some great drawings, so don't laugh too bad. So then they'll go in, they'll actually bed them up. Now these beds, one of the farmers I work with, he put in some new beds this year. They're about 3.5, 4 foot tall. So some of them have ridges, some of them are points. They'll go in thereafter and plant blueberry plants, brand new blueberry plants. And again, tile drain down here below it, or drain tile below it. As those blueberries start growing over the years, you notice the top didn't grow, only the roots did, but that's just my drawing abilities. But the roots do not get down even to where the cuts are. So these root systems are only about 6 to 8 inches in the soil. They fertilize them in the spring and in the fall. Again, with this soil being drainage of 1.5, 2 inches per hour, when we put water on, if they don't drain it, we get water sitting in between them. We get water in the beds. But when they do drain it, this water and the fertilizer will go through and down to the drain tile. But how do we deal with it? And that's what we're trying to figure out, is how much is coming out and when it's coming out, and how do we deal with that? So the site we're working with, there is right where the star is, about a 24 or 36 inch ADS pipe, 20 foot deep. The drain tiles from this approximately 60 acres drains into it, and then the farmers actually have a pump in the bottom of that well. They then pump the water out into one of these channels, and this is what it looks like when it's pumping. So we've set up ISCO samplers there to monitor this water. We sit there at this little outfall. The pump will come on for about 2.5 minutes, then it'll cut off for 2.5 minutes, and it'll come on for 2.5 minutes, and that's just a repeated cycle. It drains very well of the soil. Now, you notice this water is pretty clear. So when we were down there working a week and a half, 2 weeks ago, we cut the pump off for, I don't know, about an hour. When we cut the pumps back on, the water was coming out, I wouldn't say drinkable clear, but relatively clear. After about 10 minutes, we started getting a lot of this brown. Brown and red, if you want to look at it, is iron bacteria. So this is iron coming out of this soil. There's a lot of iron in this soil as well. There is a lot of aluminum in it at certain parts of the year for some reason. If we take a water sample of that, this is one of the water samples that we took. You'll notice it's high in iron, but there's very little to no nitrate. Now, obviously, or at least in my thinking, we caught the water sample when and outside of an irrigation event and a fertilization event. So what we're looking at is, what does this nitrate level do over the year? And again, like I said, they fertilize in the spring, they fertilize in the fall. So what we're going to try to do is capture this when they fertilize, start a week before, 2 weeks before they fertilize, capture and try to grab the soil moisture, or not soil moisture, water samples every week for about 6 weeks after they fertilize, a week or two before they fertilize, to see if we can catch any of the nitrate coming out of that system. And then monthly throughout there until the fall, we'll grab another 6 week samples just to see if we can catch that nitrate. Then the question is, what do we do with that nitrate? Because again, we'll go backwards for a minute. If you look at this water, this is very tannic water. Pretty much any water south of Macon, Georgia, is slow flowing or no flowing, or very slow flowing. Has a lot of organics in it, so the water is black. If you go to South Georgia, you look at a river or a creek down there, the water is black as a tablecloth from all the tannins in the water. DO is at 0 or below if possible. So if you look at Georgia's TMDL list, South Georgia is eat up with TMDLs. for pollutant of dissolved oxygen, which is kind of funny to talk to folks about. We've got oxygen being a pollutant, but as y'all know, no water or no oxygen in water becomes a pollutant. So adding this extra nitrate, especially in these channels, is that going to occur or help or hurt with our TMDLs? So that's kind of the Blueberry project. So we're starting that. Last year we were going to monitor it every week, every month. But the farmers come up and says, nope, we're going to use all that water for our recycle, reuse. Call the county agent again this year, and he goes, nope, they're not going to use it this year because last year they stopped all the water. They didn't pump it into the channel, and it flooded all their blueberries. So this year they're going to get it out of the way. So we're going to start the project back up again this year. I was talking to one of our row crop farmers just a couple of weeks ago, and he said, yeah, I got tile drain under my cotton and corn and peanuts as well, mainly cotton and peanuts. So this is his site in Crisp County, which is just about middle of the state. So we're going to start monitoring these drain tiles as well to look at blueberries on one side, cotton and peanuts on the other. And so the main thing is all these soils are the sandy loam or loamy sand soil. Both those sites have very high drainage, have very high infiltration rates in them. Both of them have very shallow water tables, so we're going to look at what does those nutrients do, how do they get in, and really how does it go back to these regional water plans, and how do we deal with nutrient management and non-point source pollution from agriculture in that respect. So with that, I'll finish up, John, since you stood up, and I'll see if y'all got any questions.